Okay. So this one, there's a lot of wordy stuff in here, just kind of talking about meanings of all of this stuff. But we're going to hit the important pieces here. Indefinite integrals, we've already done these. We just weren't writing them that way. We were doing antiderivatives where we had the plus c's because we didn't have numbers to plug in. And then later on we came along and started doing integrals when we had our starting and stopping points, so we had numbers to plug in. But at that point we learned that the integral is the antiderivative. So a definite integral is like when I'm integrating from 1 to 4. And we do the antiderivative, and then at the end we plug in the 4, we plug in the 1, and we subtract them. Indefinite means I'm not going to give you numbers to plug in, so we do the antiderivative, and what has to go at the end? Plus c. So that's all the indefinite integral is saying. So we've kind of already talked about this. Keep in mind then, in a definite integral, you have numbers to plug in, so your answer will be a number at the end. Indefinite integral, we don't have any numbers to plug in, so we're getting a function at the end. So if I asked you to do the integral of 10x to the 4th minus 2 secant squared x dx. We know the integral and the dx go together. So when we do the antiderivative, both of those go away. What is the antiderivative of 10x to the 4th? Minus 2. What has a derivative of secant squared x? And then what goes at the end? And you can check yourself. If you do this derivative, you should get that function. And we do. Let's see this one. If I asked you to do this antiderivative, all right, can we do the antiderivative of a quotient? No. So I have to somehow rewrite this before I'm going to be able to work it out. Do you guys have any ideas? Okay, what if we break it apart? Because we have a sine squared on the bottom. So you could say, well, this is a cosine over sine. And then we have a 1 over sine left. What is cosine over sine? What is 1 over sine? Okay, I still have things being multiplied, so it's not altogether better. However, do we know anything that has a derivative of cosecant cotangent? Cotangent. What is the derivative? The derivative of cotangent is negative cosecant cotangent. Remember, all the cos had a negative derivative. So the antiderivative would be, oh, not cotangent, cosecant. I said cotangent. Derivative of cotangent is negative cosecant squared. Derivative of cosecant is negative cosecant cotangent. Sorry if I confused you there. Thinking one thing and saying another. And then what else do we have to have? So the only reason we were able to do this antiderivative of a product was because the derivative of cosecant is that product. So it was one that we've seen before. All right. I have a couple definite integrals mixed in here just to make sure you guys are paying attention between the two and that we don't forget any skills. So this one, is it definite or indefinite? Definite. So what kind of answer will I get? A number. So what is my antiderivative? 3x squared. Do I need the plus c in this case? No, because we're going to plug in our 0 and our 3. Let's try it without a calculator. 3 to the 4th would be 3 times 3 is 9. 9 times 9 is 81. Times 1/4 would be 81 over 4. Okay, 3 squared is 9 times 3 is 27. Minus, if you put in a 0, we get 0 minus 0. Okay, to subtract, we need a common denominator. 27 times 4 is 108 over 4. So if we subtract, we get negative 27 over that.
And we don't need a C because we can plug in those numbers.
Yes.
So the only time we do need a C is when we don't have that to plug in, right?
If you had put in a C here, it wouldn't necessarily be wrong, but when you do this, you'll have plus C and a minus C, and they end up canceling.
You got it.
All right. If I want this integral, what is the antiderivative of 2x to the third? Minus, what's the antiderivative of 6x? Okay, this is like a 3 times 1 over x squared plus 1. I had to put this in here after I was mean to you on your homework. What has a derivative of 1 over x squared plus 1?
Tangent inverse.
Tangent inverse x. All right, so if we plug in 2 to the 4th is 16 times 1/2 will be 8. 2 squared is 4 times 3 is 12. 3 tangent inverse of 2. That's saying, like, for what angle does tangent equal 2? Is that one we know? Okay, I'm just going to leave it for a minute. If I put in 0, we get 0 minus 0 plus 3 tangent inverse of 0. So we have negative 4 plus 3 tangent inverse of 2. Tangent inverse of 0. What that means is tangent of what angle equals 0. So if you think about our hand trick, tangent square root of the top over square root of the bottom, when is that equal to 0? At 0. So this whole term becomes 0. So that's my final answer. Why don't you guys try the next one? Remember, simplify first. Okay, so we have to reduce subtracting exponents. So 2t squared over t squared is 2. T squared square root of t. That's like t squared times t to the 1/2. The t squareds drop on top and bottom, but we have a t to the 1/2 left. Minus, what does this term become? Okay, add 1 to the power. So we get a 2t. This becomes a t to the 3/2. We need a 2/3 in front. Okay, this becomes t to the -1, so we need a negative in front, which makes it a positive from 1 to 9. All right, let's practice our non-calculator skills. We can do this. 2 times 9.
18.
Okay, this is 2/3 times the square root of 9 cubed. The square root of 9 is 3. 3 to the third. 27. Okay, divided by 3 would be divided by 3. 27 divided by 3 is 9 times 2.
18.
That was a struggle. 9 to the -1 means minus. Let's put in 1. 2 times 1 is 2. 1 to any power is still 1 times 2/3 is 2/3. And 1 over 1 is 1. So we get 36 and 1/9. You could put that together if you wanted. Minus 3 plus 2/3. So 3 is 9 over 3 plus 2 over 3 is 11 over 3. Alright, so let's keep going. 36 times 9. It's like, you could take it times 10 if you wanted, then subtract 36. Plus we have that 1 already on top, so take it to 325 over 9. Okay, 11 over 3, we need it over 9, so if you multiply by 3 on top and bottom, 33 over 9. So 325 minus 33. What would it be? What'd you say? See, look at us. No calculator.
Why can't we combine the 36 and the 9?
This is a mixed number, so to write it as an improper fraction, you do 36 times 9 and add the 1. Okay. Last thing that we're really looking at is applications, just some situations where integrals are important. One of them is net change. Integral is the overall change. We've talked about it in terms of areas under a graph, but it can also tell us how a function is changing over time. So areas where you see that, if you looked at like volume of water in a reservoir, the derivative is the rate the water is flowing out. So the antiderivative of that rate would give you the amount of water that has changed. Another one, if we were looking at C of T being the concentration of a product in a chemical reaction, the derivative is how that concentration is changing. So the integral would, the derivative is the rate of change in our concentration. So the antiderivative gives you the actual amount of change. If we're looking at a function that maybe this was measuring the mass of a rod over time, okay, then linear density comes from that. Linear density is the derivative of mass. So the antiderivative would go backwards, and it would tell you the mass of the segment between 2 points. If we are looking at population growth, okay, the rate of change is your derivative, so the antiderivative would give you the amount our population has changed. So lots of situations. We've seen marginal cost as the derivative of cost. So the antiderivative would actually tell you the amount the costs increase, not the rate it's changing, but the actual amount. If we know the derivative of position is velocity, so if you're doing the antiderivative of velocity, you're going backwards 2 positions, so we'll give you how the position changed between 2 points in time. So all these things that we talked about with derivatives going backwards, we have those as well. We know area, when we're looking at area between a curve and the axis, above is positive, below is negative. We can also talk about, there's 2 different terms, displacement and distance. So if I take a ball, okay, and I roll it, it hits the door and it rolls back. Okay, if I ask you for the total distance that ball traveled, it traveled all the way to the door. Do you start subtracting your distance when you come back? No, you would add those. So that's like an absolute value. So if I'm asking for the distance it traveled, that's the absolute value. But if I ask for displacement, that's how far is it from starting point. So we go all the way here, and then we come back. We're getting closer, so we would subtract those off. So that's the difference between distance and displacement. Displacement, we're just integrating because it's how far is it from where it started. If I want the total distance traveled, though, we have to think in terms of absolute values, because even if you're going backwards, you're still traveling that distance. All right, so let's take a look at this example. A particle moves along a line, so the velocity is given by this equation. Find the displacement of the particle between 1 and 4 seconds. So displacement means we want to know how far it is from where it started. So we are just going to integrate. And we actually don't even have to break things apart. We just need to integrate from 1 to 4. And displacement is talking about position. The function I gave you was velocity, so that's why I'm doing the antiderivative, because the antiderivative of velocity is position. So this would be a 1/3 t cubed minus 1/2 t squared minus 6t from 1 to 4. So if we put in a 4, we get 64 over 3. 4 squared is 16 times a half is 8. Minus 24. Minus, we put in a 1, that's 1/3 minus 1/2 minus 6. So if we work this out, so what does it mean to have a negative displacement here? It's behind where it started. Okay. If I want the total distance traveled during my time period, okay, that's talking about the absolute value. So when I integrate, I have to do the absolute value of my velocity. If we are going to do the absolute value of this, what do I need to know? So we could think of that as 2 minus 3, t plus 2. Is -2 in my interval? No, we can't have a negative time. So when I'm doing this, we're going to have to go from 1 to 3. And then from 3 to 4. Okay, if you put in a number between 1 and 3, even if we put in a 1 itself, we get 1 minus 1 minus 6. That's a negative. So the absolute value would make it positive. So we'll do the opposite of this. Okay, if we go between 3 and 4, even if we put in a 4, 16 minus 4 minus 6, that's positive, so the absolute value doesn't change. So then we do our antiderivatives, so that would be a negative 1/3 t cubed plus 1/2 t squared plus 6t minus 1/3 t cubed minus 1/2 t squared minus 6t. For the sake of time, I'm not going to work this one out in my head. So we plug in and we get 61 over 6 for our final answer. So you would definitely show a little more work, but for the sake of time, I'm not going to write it all out. Questions on that one? I think I am going to stop there. There is one example left that we might do at the beginning of class tomorrow. So if we look at, make sure you are reading the directions. The first two questions, they are actually telling you the antiderivative, and they're wanting you to prove that it's correct. And how do you prove that you have the correct antiderivative? Do the derivative. So they're wanting you to do the derivative of their answer and see if you get what you were originally integrating. So just practicing that skill of checking yourself. As far as when this is due, I am not going to collect this until Tuesday, so Thursday. But I will probably do some other things in class tomorrow, so you're not just going to have a whole class period to work on it. So you have some time today. You will have some time tomorrow, but don't come in expecting a full class